This video is a commentary on the paper titled A Lookahead Growth Model with a Monetary Variable by K. Kobayashi. This paper introduces a monetary variable into the model of the author's previous work, A Lookahead Growth Model with a Non-Productive Asset. You can find these papers on SSRN, which is one of the preprint sites for social science. Here, I provide the summary of this commentary. Deflationary state is as follows. In an economic environment that the economy without money would be in equilibrium at a negative interest rate, because of the existence of money, the interest rate cannot go to a negative rate, it remains near zero and the supply-demand gap continues. This gap increases the real value of money, that is, the price level decreases if money stock is constant. That is deflation. Because this situation continues, it is called the deflationary state. If the government expands fiscal spending to fill this supply-demand gap, it can escape deflation, but this leads to a growing fiscal deficit. If the government tries to fill the growing deficit by raising the consumption tax, the economy will return to deflation. In a normal economic situation with a positive interest rate, fiscal financing causes large inflation, but in the deflationary state, fiscal financing does not cause large inflation. Moreover, if the fiscal deficit does not exceed the supply-demand gap, inflation does not occur. Here's the outline. I will show growth model with monetary variable. However, before explaining the behavior of this model, I'll show the behavior of the model without monetary variables. Next, I explain the behavior of the model with a monetary variable and the deflation state. I will also show fiscal policy for anti-deflation and indicate the effect of raising consumption tax. Finally, I will show inflation rates for financing government's fiscal deficit. This is the simple growth model, shown in the last section, conclusion, of the paper. KT is capital stock at time t. MT is real value of money at time t, which is money stock divided by price level. Delta KT is the difference of capital between time t plus 1 and t. Delta MT is the difference of real value of money between time t plus 1 and t. Z is net production function in terms of capital KT, which is defined by production function Y minus depreciation. C is consumption function and G is government spending. This growth model shows that what remains after subtracting consumption and government spending from the net production function causes an increase in capital and/or in the real value of currency. Here, we explain the relationship between the total production function, the net production function, and the interest rate on capital K. This is what is written in theoretical economics textbooks, so we will only summarize the main points. The production function Y increases as capital K increases, but the rate of increase declines. Therefore, the net production function Z, that is, Y subtracting the depreciation, increases at first, but begins to decline at a certain point. The interest rate for those who invested capital K is the derivative of ZK, which is equivalent to the slope of ZK on a graph. Therefore, for example, at point A on the graph the interest rate is positive, at point B it's zero, and at point C it's negative. Here, capital KG at point B is referred to as golden rule. I'll discuss the model without monetary variables, which is one in which net production minus consumption and government spending equals increases in capital. That means that net production is allocated between consumption, government spending, and investment. Let K star be a solution of the right side equals 0. If capital is less than K star, capital K increases. In the opposite situation, it decreases. Therefore, K star is an equilibrium and stable point. In some cases, the equilibrium point has a negative interest rate as shown in the figure. In well-known theories, equilibrium points can only exist at positive interest rates, but the paper shows that equilibrium points with negative interest rates also exist. I'll show the behavior of the model with a monetary variable. Consider an economical condition that, without money, the equilibrium point has a negative interest rate. In the area with positive interest rates, that is, where capital is less than the golden rule, the increment in the real value of money is near zero, and thus the behavior is roughly the same as in the model without money. However, as capital approaches the golden rule, that is, as the interest rate approaches zero, capital growth approaches zero, and then capital is almost constant. Therefore, the capital never exceeds the golden rule, so the supply-demand gap continues. This gap leads to an increase in the real value of money. From the definition of the real value of money, the increase in the real value of money leads to a falling price level if money stock is constant. That is deflation. Because this situation continues, it is called a deflationary state. As shown in the figure, to escape deflation, the government spending should be increased to fill the supply-demand gap. Under this policy, an equilibrium point exists and deflation disappears. However, increasing government spending leads to a growing fiscal deficit. If the government will fill this growing fiscal deficit by raising the consumption tax, the economy will return to deflation. Therefore, raising the consumption tax in a deflationary state is not a good policy. Here I'll show the inflation rate when the government's fiscal deficit is covered by currency issuance by the central bank, in other words, when fiscal financing is carried out. The inflation rate π(t) is represented as this equation. Deriving this equation will be shown in the next slide. dt is real value of fiscal deficit at time t. mt plus 1 is real value of money at time t plus 1. Delta t plus 1 is the difference of real value of money between at time t and at t plus 1. When an equilibrium point exists, every variable has a constant value and delta mt is zero, so the inflation rate is the real fiscal deficit divided by the real value of money. At the equilibrium point, the interest rate is positive, so the real value of money is very small. Therefore, a large fiscal deficit leads to heavy inflation. On the other hand, in the deflationary state, delta mt is approximately equal to the supply-demand gap, so if the fiscal deficit does not exceed the supply-demand gap, then the numerator is negative, the inflation rate is negative. Therefore, even under the central bank financing government's fiscal deficit, inflation does not occur in this situation. Even if this condition is not met, in the deflationary state, the denominator value becomes large, so large inflation will not occur. Let dt be the real value of government's fiscal deficit. To finance the deficit dt, the central bank issue the money of pt times dt. Then the money stock at time t plus 1 increases by the amount of issuance. From the definition of real value of money, money stock can be replaced by price level times real value of money. Subtracting pt times mt plus 1 from both sides, we have the second equation. Dividing both sides by pt times mt plus 1, we get the interest rate represented by the last equation. I'd like to conclude with a few remarks. Using this growth model, I discussed deflation and policy for anti-deflation. Using this formula on interest rates, I showed that under normal economic conditions with positive interest rates, the central bank financing a large fiscal deficit leads to heavy inflation. However, I also showed that if the fiscal deficit does not exceed the supply-demand gap in deflation, inflation does not occur. Although I did not mention it in this video, the paper proposes a new tax that deducts consumption from household income. This would increase household consumption, making it unnecessary for the government to increase spending to overcome deflation, and potentially increasing tax revenue. Therefore, it would be possible to overcome deflation without increasing the fiscal deficit. The paper does not include trade or capital transactions with overseas countries in the model, so it is unable to explain the current weak yen and high prices in Japan, but I hope that such a model will emerge. This concludes my explanation. Thank you for your attention.